This lecture is on heat and temperature and the difference between them. The first thing we have, it says being out in the heat for 2 weeks definitely drains your energy. So we'll take a look at the interaction between these two. So the goals for this presentation is to, number one, you need to understand the difference between temperature, heat, and thermal energy, and you need to be able to convert between the various temperature and energy scales. So the first thing we need to do is we need to look at temperature. The old definition that we have for temperature is it is the property of matter that tells you how hot or cold an object is. And that's a pretty good definition. However, you start to get into things like, why does a piece of metal feel cool and a carpet feel warm when they're in the same room? So we really need to define temperature as a measure of molecular motion. So what it is it's actually a measure of the kinetic energy of a particle. There are lots of different temperature scales that we'll go into, but the main ones are Fahrenheit, Celsius, and Kelvin. We will always use Kelvin in this class for the reason that it is an absolute scale, and it's the metric absolute scale. So if you take a look at these three objects, you see them move across the screen, you can say which one of these has the greatest kinetic energy. Well, you can take a look at them. They're all the same size. So the big difference right here is the fact that the bottom one moves faster. Because it has a higher kinetic energy, it's said to have a higher temperature. So there's temperature conversions between the scales. Now, the U.S. is the only country that uses Fahrenheit as its standard unit of temperature. Other countries use Celsius, and science uses Kelvin because it's an absolute scale. The fact that there is no negative temperatures really makes the Kelvin scale very, very, very useful. So right here you see how to convert between Fahrenheit and Celsius. You plug in the Celsius, you get the Fahrenheit. You plug in the Fahrenheit, you get the Celsius. And you plug in the Celsius and you can get the Kelvin. So the trick is that no matter what, in order to get to Kelvin, you have to use Celsius as kind of an intermediary. Absolute zero. That is the lowest possible temperature in any of the scales. Remember, temperature is defined as the amount of kinetic energy that an object has. So zero would be zero kinetic energy. That would be the when all molecular motion ceases. In other words, the velocity of a particle is zero, then it would be said to be at absolute zero. Now, absolute zero hasn't been reached, and it never will be reached because it violates some other laws of physics that we'll talk about a little later in the year. But for now, realize that 0 Kelvin, 0 K, is the absolute lowest temperature that you can possibly have. Now, thermal energy is different from temperature. Thermal energy is the total internal energy of a system. It is related to temperature, but it is also related to mass. Thermal energy does not equal temperature. So you can have various objects, say one object that's very, very small, like a cup of coffee that's very hot, and you can have a swimming pool, and the swimming pool is going to have more thermal energy in the system because it's got more energy. It's just got a lot more mass that can make up for it. So whenever you're comparing objects, you have to look not only at the temperature of the system, but you also have to look at the overall mass of the object as well. One key thing that we need to talk about is thermal equilibrium. Thermal equilibrium is when objects are at the same temperature. Now, all objects will seek to go to thermal equilibrium. Even if you have these two blocks right here and they're separate, some heat will leave this and go to this. Now, if you touch them, it's going to be more likely that that's going to occur. Now, thermal equilibrium does not mean that there is not heat transferred. It just means that the net movement of heat is equal. You guys learned about equilibrium last year in chemistry, and you should know that it doesn't mean that you stop the reaction. It just means for every one that you go forward, there's one that goes backwards. It's the same thing with thermal equilibrium. So objects must be at the same temperature to be in thermal equilibrium, and all objects will move toward thermal equilibrium. In fact, the more contact, the more likely it makes, but all objects will move toward thermal equilibrium. Now, heat is also a measurement of energy, and since it's a measurement of energy, it's going to be measured in joules. A calorie is also a measurement of energy, and you may be more familiar with calories for nutritional labels and so forth. But heat is a type of energy. It's related to temperature. It's related to thermal energy, but they're not the same thing. The common conversion factor that we have for energy is there are 4.184 joules in a calorie, and if you notice, this is a small c calorie, and there are 1,000 calories in a capital C calorie. Now, the actual term for this is a kilocalorie, but they tend to not put the K in front of it. They just tend to make it a capital letter so it can be confusing. So if you were to look at a nutritional label, this is actually a kilocalorie, 60 kilocalories, not just 60 calories. Now, what is heat? Heat is the movement, it's the energy that moves in order to equilibrate temperature. So we already said that objects will seek to be in thermal equilibrium. Well, in order to do that, they have to transfer energy, and that energy manifests itself as molecular motion. So when you have one molecule transfer energy to another to equilibrate their temperatures, we've said that heat's moved. You need to be able to convert between joules, calories, and kilocalories in order to make sure that you know how to do heat. So you should know, learn, memorize, recall all of the information that was above. You need to understand the definitions of temperature, heat, thermal energy, how to convert between the temperature from Celsius to Fahrenheit to Kelvin, from joules to kilocalories to calories. You need to be able to do all of that as well as know the definitions of each.